So we're going to multiply perfect squares, and we're also going to multiply when what it's called is the signs are interchanged. Like if you look at these problems, one's plus and one's minus, otherwise they're the same numbers. Okay, these are called special cases. In a way, there's nothing special about them. You can do them just like normal, but there's a pattern about them that's exactly the same. Okay, that you always see. So the way to do this when you're squaring it is, first remember, it is not x squared plus 9. When that happens, that means somebody has applied the square to both things as if they were distributing it like you would a coefficient or a number in front. But it's not true. That is not that. Because remember what a square means. If I have 7 squared, that means I'm doing 7 times 7. When I do 7 squared, you're so used to it, you immediately think 49 because you know the multiplication tables. You just think 7 squared is 49. But the reason it is because you're multiplying that number to itself, the same number, you're doing it 2 times. That's what the 2 means. So if you're going to do that, do it for the other thing. Do it as x plus 3 times x plus 3. And we do the same thing we did in the last section. That's x squared. That's plus 3x plus 3x plus 9. So that's x squared plus 6x plus 9. Now, I'm going to circle this thingy, but I'm going to do a little thing about this here. I'm going to analyze it. Whoops! If I'm going to analyze it, I better not have it just disappear on me. I like this little writing program a lot, but I don't like how it goes haywire when I try to go over something. Come on. Look at these numbers and look at that number. Special relationship between the original number and these two. This one is 2 times 3, and this one is 3 squared. So when you have a perfect square, you can take that number and double it for b and use the square of it for c. And b and c, what I mean is that's where all of these are written in this polynomials are an ax squared plus bx plus c. And the coefficients of a, b, and c are the coefficients of the x's are a, b, and c. And so the b is always the coefficient of the x term. The c is always the coefficient of the x to the 0 term, of just we call it constant because there's no x with it. And the a is always the coefficient of x squared. And that's why in this case, yeah, okay. So when I look at this one over here, oh, and the sign stays the same for the middle one. So when I look at this other one, this next one here, I know immediately I can do x squared, and I can double this to make it negative 6x, and I can square it to get the end. Okay, and say I come down to the bottom ones, okay, I can do, now this one's different. That's when you don't have, you look at this, now I've got this 2 that complicates things only for the first part, okay? So let's work it out and see what happens and see how that pattern holds. So it's 2x plus 3, 2x plus 3, because this is now a complicating factor. So I get 2 times 2, so I get 4x squared, and then I get plus 6x, and I get plus 6x, and I get plus 9. So I have 4x squared plus 12x plus 9. Okay. So in analyzing this, I see that this number is the 2 that's being squared. This number, don't go away these things. This number 12 is double the 2 coefficients. It's like this one where it's 2 times 3, but now it's 2 times 2. Look, here it is, 2 and 3. So you multiply those, and then you double that. That's how I got 12. This one is still the same. That's the 3 that's squared. So you square both of these numbers for the end ones, the beginning and the end. You multiply them and double it for the middle term. Now it's gotten a little bit complicated. This one's a little easier to remember. This one here, now there's too many parts to it. So many of the textbooks, and I think ours shows this too. It shows us in it shows it in that pattern of times the double the for that number and square it there. I don't think you should care about it. I think you should just multiply it out like this. If you just multiply it out like this, you're going to be right, and you don't have to think about it twice. Okay. So like on this one here now, I know I'm going to get the same thing but with a negative there, but I'm just going to multiply it as if it was just a normal everyday problem as opposed to a special case. So I don't have to think of it as a special case. I just have to multiply it. Okay, squaring it, so they're both negatives. 2 times 2 is 4, and 2x's is x squared. And I do these two for minus 6x, and these two for minus 6x, and these two for positive 9. That gives me 4x squared minus 12x plus 9. I got the same answer without having to think too hard about it. I don't have to worry about the pattern here. In some cases, the pattern is absolutely essential, and you've got to do it, but not always. And here's one where I don't. Okay, these two I'll leave for practice if anybody wishes to, and when I post this, I'll have the answers posted for it. Now, here is the different special case. These ones, they are not squared. All right, so we don't see like x plus 3 squared, because that would be 2 of them being both plus, and this one's not plus. If it was x minus 3 squared, I'd have x plus, I'd have a plus but a minus. I'd have x minus 3 and then another x minus 3. And this one's not minus. So that means it's not those things. So don't get stuck and hung up on one way of doing it when this one's not it. A different thing. Instead, I'm going to do x times x and x times negative 3, 3 times x, and 3 times negative 3. So that means x times x is x squared. And then this one's negative 3x. This one's positive 3x. And this is a negative 3 times 3 is 9. And notice now about these two in the middle. Well, if they stay and don't go away on me. Okay, they cancel out. So I get x squared minus 9. And that would be my answer for this. And that's because if one is positive and one is negative, and they're otherwise the exact same binomials, then the middle terms are going to cancel out. And I'm simply going to have this, the two other ones squared, but not canceling out a negative because one's plus and one's minus. Now, in the future section, we're going to take this and we're going to be breaking it down and going backwards to that. But we'll do that later. And that's just simply memorizing that if you have a difference of two perfect squares, you just split them up. Okay, now over here, I'm going to look at this and think the same thing. 2x times 2x, that's 4x squared. And then 3 times negative 3 is negative 9. I would normally never do that except knowing that because they're exactly the same except the plus and minus, then the two middle terms, which is negative 6x and positive 6x, are canceling out. And so this is all that's going to be left. But you have to have your wits about you with that. You can't make a mistake with that. And it's better sometimes to actually multiply out every part of it and let the two middle ones cancel themselves out when you're doing it. Suppose I should have that here. Minus more in the middle. Okay. Looks weird, but still. And then there's some other practice ones. Let me do a couple of these here. Okay. 5x times 5x is 25x squared. Oh, I forgot the square here. I'll bet you someone is mentioning that because you caught it faster than I did. It should indeed be 4x squared. And when I started doing this one, I started thinking about it, wondering, did I forget to put the square? And I did. Now I got both of those correct. The square on there. And if I did the middle terms, I get negative 20x plus 20x. So I'll write them down anyway, just because the teacher was supposed to write them down. And then I'll cross them out because they cancel out. And then minus 16. So 25x squared minus 16. And then I'm going to do one of these bottom ones because they have a y in it. It doesn't matter that there's a y in it. Keep the same steps. Do the same procedures. 25x squared. Okay. And I'll do the middle terms as plus 10xy minus 10xy. So those cancel out. And then minus 4y squared. So this one becomes 25x squared minus 4y y squared. That's about the most complicated that this one kind is going to get, with both having variables. So look at these, think about what's happening with these two, and make sure you can replicate these. You will see them again, not only on my test, but also in various problems and so on, and you'll see them regularly on my tests. Especially when we do the factoring, I'll be going backwards. Okay, so let me step up here. What's on my next one? An application problem. All right. So let's figure this out. When you have word problems, just figure out what it's saying. Most word problems scare people, but most word problems are easily broken down into something that can be understandable if you take your time to look at it, think about what it's saying, use essentially common sense. Okay, so a backyard deck has a length and a width, and it doesn't say it's rectangular, but you sort of can pretty much get that idea that you have a rectangular one because you have a length and a width. So I'm going to draw one here. It has a length of x plus 11, and it has a width of x minus 1. So if x was 20, it would be 31 feet for length and 19 feet for the width. If x was 50, you'd have 61 and 49. So it just depends on what x is. There's a swimming pool inside it, and it sounds like that swimming pool is is x plus 7. So it seems like it's rectangular, x plus 7 and x minus 7. So we have a problem like I did on one of the other sections, the last section before this. We're going to have the x plus 11 times x minus 1. That's the area of the whole thing. And then the swimming pool part here, where the water is, okay, all of that, we're going to subtract that. So what we're really going to do is we're going to do x plus 11 times x minus 1. That's the area of the large one. Subtract the area of the smaller one. And that's x plus 7 and x minus 7. So here, now, I'm going to be doing x times x is x squared minus x plus 11x minus 11. So let's check these. X times x is x squared minus x plus 11x. That looks good. So I have an x squared plus 10x plus minus 11. Over here, not worrying about that subtracting yet. Okay, so I'm just going to do this part here. X times x is x squared. And then I have minus 7x and plus 7x. They cancel out. And then minus 49. So I'm subtracting that. So another way I can then think about doing is subtracting x squared, and then minus times minus makes it plus 49. Because I'm subtracting both of these when I subtract. It's sort of like a negative 1 times x squared and a negative 1 times a negative 49 to make it plus. So now x squared, take away x squared, cancels out. I have only one x term. And I have negative 11 plus 49. 49 take away 11 is 38. And that represents the area of the deck. Let me double check my numbers here. Okay, so I've got minus x plus 11x minus 11. X squared minus 49. Okay, that should be 10x minus 11. Okay, I think I've got those. Let's take a look and see. Positive 49. Okay. So when I multiply these, let's put that in yellow. This is an important one. A lot of people will need to hear this, even if you think you get it now. Doing the things with the negatives is really important. It messes people up more than anything else, even when they don't realize it. So this should make sense as the result of, I don't really want to do that. I want to do x plus 7 and x minus 7. Multiply that and you get this. But because we're taking this bigger area and subtracting this one from it, we have to subtract that. And I'm doing a -1 times that to make -x squared, which is why that's there. And a -1 times -49 to make it +49. And that's why that's there. Okay, so I know from my explanation some people have already gotten that, but I wanted to go over it again because subtracting this, doing this out first, and then subtracting the two things and making sure you don't forget to subtract that one is really, really vital. Okay. This next problem is sort of the same idea, but now it's with a circle instead of a rectangle. I'll show you it starting it, and then you can think the same thing. Notice I'm going to do that. You're not required to draw something out, but I'll tell you right now, it is one of the by far best things you can do to help yourself when you're doing a word problem. If it is something that you could draw to make sense of better, you should do that. So we have here one circle that has a radius of x plus 4, and then another circle with a much smaller radius, a much smaller circle, and that one's a radius of x. So what's the area of the larger circle? In other words, what's the area of just this part? Okay, so what we're really doing is we're trying to find the area of the big circle, take away the area of the little circle. And area of a circle is pi r squared. So what we're doing is we're doing pi r squared for that one minus pi r squared for this one. So we know the radius is x plus 4. That's pi x plus 4 squared minus pi x squared. Okay. See how I set this up where I'm trying to make sense of what it is that I'm doing. The area of one, take away the area of the other, put the formula in for them, and then I plugged in the thing for it. And this problem is here, or allows us to, to practice our skills. Take that one, just like that. Let's hope it, come on, stay. There, we're going to do that. So I have pi on the outside of it. X times x. Oh, now over here I should do x plus 4 and x plus 4. So I get x squared plus 4x is plus 8x and plus 16. X squared minus 8x plus 16 minus pi x squared. And then I should do these out. So what I do is I have pi x squared minus 8 pi x minus 16 pi minus pi x squared, and notice this, they go away. So the area is actually negative 8 pi x minus 16 pi. Whoops, I made a mistake. I don't know if anyone caught it yet, but hold on, let's look at it and I'll show you the mistake in here. Okay. For some reason, I don't know why I did this, but for some reason, when I did x plus 4 and x plus 4, I don't know why I got a negative here, because 4x plus 4x is positive 8. I don't know why I wrote that as a negative either. Okay, so I got those back. Now I have those right, which means these are plus. So it's actually plus 16. Notice the order here. We usually put the variable at the end of the other numbers, especially since pi is a number we could multiply with if we wanted to. We'd have to round it to 3.14, but we can do that. Okay, and that is another step. Oftentimes it can be left this way. Okay, so this is an acceptable answer, and this is considered an exact answer because we haven't rounded anything yet. Okay, and for prox. And what you do is you check to see what the answer says. Oh, first let's finish this. If I do calculator 3.14, use the pi button also, but 3.14 is a little easier for most of us, and it's more common actually for things. That's 25.12x plus 16 times 3.14. 50.24. So we have two possible answers here. Okay. And if the problem doesn't tell you which way to do it, then you do it either way. If the problem says give an exact answer, then you would do this. This one's exact. So an exact answer means don't do anything that's going to involve rounding. Usually we deal with that with square roots, but here we can do it with pi. So leaving it with pi in the answer is acceptable, unless, you can choose not to do that unless the problem says exact.